Hi there, folks. Today we're going to be talking about Module 5, Probability and Counting Techniques, and we are just doing a brief introduction. If I'm being honest, this is probably going to be the hardest module in this course because some of the computations and some of the ways that we have to think about the problems is going to be a bit more advanced. That said, we'll work through it. There we go. So Module 5, Probability and Counting Techniques. Mathematics is all about certainty and how we can use rigorous definitions and conditional statements to divine truth. Probability is very closely related. It is a field which uses the tools of mathematics to measure uncertainty. Probability isn't just about counting cards or flipping coins, it's about decision making. When there are unknowns, probability can help ensure you have the highest likelihood of a favorable outcome. We will often be using some of the simplest examples, things involving dice and coin flips and cards, because these are things which are tangible. These are things which are countable. I mean, there are 52 cards in a standard deck of cards. We can understand what's going on with those decks of cards. If you've never seen a deck of cards, go get one. They're cheap, they're easy to use, and they will help us understand this stuff a little bit better. To begin with, though, let's talk about sample spaces and events, because these are really at the forefront of what probability is all about. And so when we think about flipping a coin or rolling dice or pulling a particular card from a deck, the probability is based on two things. The first is the sample space. And so what are all of the possible things that could happen? And the second is the event. Which of the possible things are we interested in? We could be only interested in one thing. We could be interested in multiple things. And being able to understand that is going to be key. The probability of an event occurring is given by the following formula. The probability is equal to the number of outcomes in the events divided by the size of the outcomes in the sample space. And so here's a simple example. In a deck of 52 cards, there are 4 kings, 2 of which are black and 2 of which are red. The probability of pulling a red king from a deck of 52 cards is 2 out of 52, because there are 2 red kings and 52 possible cards. And so the number of outcomes in the events, the number of things which we're interested in, is 2, because there are 2 red kings. The total possible outcomes is 52, because we could pull any of the 52 cards. If we want to, we can write this 2 out of 52 a number of different ways. We could reduce it to 1 out of 26. We could convert it to a decimal. We can convert it to a percent. Depending on what you're dealing with, you'll see it written a lot of different ways. Oftentimes, you just see it written 1 out of 26 or 2 out of 52. All of those are okay. That said, that's the biggest picture, but we're going to be getting much more particular with some of the stuff we're going to be doing. Uh, since our goal with probability is to count possible outcomes, we need to get really good at counting. And that is something which is a challenge for folks. Example 1, if I flip a coin and roll a 6-sided dice, how many possible outcomes are there? Outcome 2, or example 2, how many possible ways are there to pull 2 cards from a deck of 52? Now, depending on how much experience you have with probability, these might be really easy problems. But for a lot of folks, these are really challenging ones to wrap your head around. And so let's make sure that we understand these basics. The typical strategy and the fundamental counting principle is we would multiply the number of outcomes. And so in example 1, we are flipping a coin, which has 2 outcomes, and we are rolling a 6-sided dice, which has 6 outcomes. And so multiplying those two gives us 12 outcomes. Basically, we could get heads and all 6 of the outcomes for the dice, or we could get tails and we could get all 6 outcomes for the dice. And so that brings us to 12 possible outcomes for the combination of flipping a coin and rolling a dice. Example 2, it's a little bit trickier. And so in example 2, how many possible ways are there to pull 2 cards from a deck of 52? Well, there are 52 ways to pull the first card, but once removed, there's only going to be 51 ways to pull the second card, making the total possible ways to pull 2 cards 52 times 51, which is 2,652. And so 2652 different ways to pull 2 cards from a deck. One thing to note, this would be different if after we pulled the first card, we put it back in. If we put that card back in, instead, it would be 52 times 52. This idea of replacement and the idea of order is going to be very key in understanding all of the different situations which can happen when it comes to probability. One such example, and I put this as advanced counting, is permutations. And so here's a sample problem. Suppose we have 6 colors, red, orange, yellow, green, blue, and violet. And we wish to use 3 of them in a painting. One for the background, one for the foreground, and one for highlights. How many possible ways can we select colors for this situation, assuming we aren't repeating colors? So you're not going to have red, 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 orange, 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 or something like that. In this example, we could just count it out, but there's a lot of possibilities. If we wanted to use the fundamental counting principle, we could instead say that there are 6 options for color 1, 5 options for color 2, and 4 options for color 3, leading to a total of 6 times 5 times 4 is equal to 120 different options. It's a lot of different options, and so writing them all out might not be so fun. In this case, the order does matter. And so if you are picking red for the background versus red for the foreground, those are different situations. Our next example is not going to have that, and that'll be the key difference between the two. This is an example of a permutation problem, an arrangement of distinct objects in a specific order. In general, the arrangements of n objects in a specific order using r of those objects is called a permutation of n objects taken r at a time. And we have a formula which will allow us to calculate it. In this case, our n was 6 because there were 6 total colors, and our r was 3 because we were choosing 3 of them. And so if we do 6 factorial and we divide it by 6 minus 3 factorial, we should get our 120 number. Now, this next example is a little bit different, but really it's just a slight difference. And so suppose that we have 6 colors, red, orange, yellow, green, blue, and violet, and we wish to select 3 of the colors for use in a painting. How many possible ways can we select the colors for this situation? In this case, instead of being specific with this one's for the background, this one's for the foreground, this one's for the highlights, we're just saying we're going to choose 3 colors and just use them in whatever places we deem necessary. And so, yeah, this is slightly different than the last example because here we would consider the combination of red, orange, yellow the same as red, yellow, orange, or yellow, orange, red, or yellow, red, orange, or orange, red, yellow, or orange, yellow, red. All 6 of those are the exact same option. And so each color combination is represented 6 times in our permutation example. When we think of our last example, every single one of them will be repeated 6 times. And so in order to solve this, all we would have to do is just divide our permutation problem by 6. And so we had 120 as the solution for the permutation problem. Dividing that by 6 gives us 20 possible solutions. This is actually how we come up with a formula for this. This is an example of a combinations problem, a selection of objects without regard to order. The number of combinations of n objects taken r at a time without replacement is written and calculated as the following. You'll notice that this is the exact same thing, but we're adding an r factorial term. In this case, our r was 3. because we were picking 3 colors. And sure enough, 3 factorial is that 6. And so we are taking our NPR and dividing by r factorial. And that will give us the number of combinations where we don't really care so much about the order. Let's do one more problem, just so that we can start to see how these things can get a little bit trickier and messier. Suppose that we have 6 colors, again, red, orange, yellow, green, blue, violet, and we wish to select 3 of the colors for use in a painting. What is the likelihood that 2 of those colors are red and orange? And so in this case, the possible outcomes are a combination. And since we are picking 3 from these 6 colors, there are going to be 20 possible outcomes. If you want, you can try plugging that into the formula before to double check. The event we're interested in is a red and an orange. And it could only happen in 4 different ways. It's either going to be red, orange, yellow, red, orange, green, red, orange, blue, or red, orange, violet. Because there are 4 possible outcomes, which are the ones we're interested in, out of 20 total in the sample space, we could say that the odds are 1 out of 5. Note, these problems can get very, very messy. These are some of the simpler introductory problems. And there's a reason why we're going to spend a little bit extra time working through the probability this semester. The problems can get a little bit more challenging. Trying to wrap our head around them is going to be a little bit trickier. And I would highly recommend, if you start feeling a bit of dread when it comes to this stuff, hit up tutoring as soon as you possibly can. We want to get you to succeed through this, and I'm worried this is going to be the hardest module. And so do your best to get through it as quickly as you can. That said, that is our brief introduction to Module 5, Probability and Counting Techniques. I want to wish you all good luck on this. You're going to have to fight through it, I think, but you can do it. Good luck.